We will now talk about tree-based models, namely decision trees and random forests. Now these models are quite different from linear regression and logistic regression, and hence it's worth including in this intro tutorial. So let's start with decision trees. Decision trees can be used both for classification and for regression. Let's see how it works, starting with classification. Let's say we want to classify a person as being fit or unfit. We will start at the top of this tree. This is a already fitted decision tree, and we'll ask how old is this person. If they are less than 30, if the age is less than 30, we will go down the left path. If they're older than 30, we'll go down the right path. Let's say they're younger than 30. If they're younger than 30, we'll ask the question, do they eat a lot of pizzas? We'll look at this feature, and if the answer is yes, if this feature is equal to a 1, we'll classify them as unfit. If they don't eat a lot of pizza, then we'll classify them as fit. On the right-hand side of the tree, if the person is older than 30, we'll ask, do they exercise in the morning? If yes, we classify them as fit. If no, as unfit. What we do in this decision tree is at each node, at each decision point, we choose a feature that we want to split on and how we want to split. Here, we split on the feature age, and the split point is 30. Here, we split on the feature eating pizzas, and well, there's no real split point because it's just yes or no. Same here. Does the person exercise in the morning? And if yes, we go left. If no, we go right. We will then make a final prediction based on how many examples, how many training examples are in the node, in the terminal node or in the leaf node that we land in. So if, for example, here 10 people are unfit and 5 people are fit, we will make a prediction of being unfit. For regression, a decision tree looks very similar, except we'll look at all the nodes, all the data points, in the final node, and we will take an average. And this will be our prediction. So we will not go into details as to how the decision tree is fit, but essentially what happens is that at each node we need to choose a feature and a split point so that the two classes or the two groups that the features separated, that the data points are separated into, are as different from each other as possible. Because in this way we can make sure that we get the most heterogeneous terminal nodes in the end that will allow for a good classification or regression scheme. Let's now move on to random forests. Random forests are essentially a large collection of decision trees. And the idea is we fit, let's say, 100 decision trees, each with a slightly different subsample of the overall training data set and with a slightly different set of features. Now these decision trees will all have their own prediction, and we will then use the wisdom of the crowd to combine those predictions into an overall prediction. For the classification case, we look at the majority vote, and for the regression case, we take the average of each individual tree's prediction. Generally speaking, if you combine multiple decision trees in this way, you'll get more predictive power than just using a single decision tree.